Okay, hello everyone, and um, welcome to this presentation on an introduction to the SaaS world, I would say. This was a presentation I presented on Ajay on JLA Summit last November, December timeframe. And yeah, as always, we always start with our Jains or females. And this is Kalpana Chawla, who was the first female astronaut from India uh, who took a robotic arm operator work in a very critical mission by NASA, and eventually that when it came back to Earth, the shuttle got exploded by 2004, and it was really a memorable and even for everyone of Indians by then. And in US, we can find in few places uh, places named after her, like the one what you see here, Kalpana Chawla Hall, which is in a very critical place. Yeah. So myself, Ajay, I work as a lead test engineer with Value Vision Systems, where we produce a lot of cameras in my division. This mainly goes for the automobile suppliers. So Value is a tier 1 supplier for the automotive companies, and most of the cameras goes for automotive like BMW or Volkswagen and so on. And here we are quite interested in improving the qualities of the camera. So we do the end of line testing, and we also do a critical process of the camera manufacturing, which is in turn done with whole LabVIEW stuff, LabVIEW and test stand. And that's me. All right. So, door to SaaS world. As the days goes by, everyone of us start to hear a lot about the SaaS, which basically stands for software as a service. And we will see what it is in detail. Here in this slide, mainly we will see about how we can think about integrating the LabVIEW to the SaaS world with some integrations like Python. And one of the framework I used recently to communicate with a few of the SaaS services. So when you come to the SaaS world, hopefully you might have heard some of the SaaS services by now, or you may be using a lot. Can you name a few of them if you know? I'm just trying to check my chat window here. Yeah, GitLab is one of the SaaS. Yeah, and a lot of them are now almost a SaaS. Whenever you see what the Google provides is pretty much a SaaS service. The email provision or the Google Drive, all your drive or software in your local machine is going up to the cloud. And when you take even the Microsoft, the Office, the complete Office has gone into a cloud. You can do everything on the cloud. You don't need a local instance of it if you want to work on your files. The Azure or AWS, Salesforce, and Atlassian, GitLab, or pretty much we are surrounded with numerous SaaS services now, and definitely one or other would have started working with SaaS connectivity from LabVIEW. So what is SaaS essentially? To put it in a word, SaaS is can be an infrastructure as a service or software as a service, where you have the complete application and the dependencies for the applications, like whether the servers or database or your real source code, everything runs right on a cloud. And as a user, you will be just using the interface of from other end, like either your mobile phone or your laptop or your the browsers. So all of them just help you as an interface to get a benefit out of that application which runs on the cloud. And by all that means you will not worry about too many details that goes behind it, even as simple detail like how to install it, how to get it running and everything. And most of them will be up there and ready for you whenever you want. Just to do a quick comparison, when you want to compare with a SaaS software versus a traditional software, in most sense, in traditional software, when it comes to the costing, the traditional software will be a one-time fee, whereas the SaaS service will be a subscription based. You might need to pay as you go. And the traditional software usually go into a single device. On the SaaS service, there is no limitation. The same application can run on many devices, meaning it can just open up in different places and you can use the same application which runs on the cloud. These are just a quick top two, but there are numerous, right? So when you use a traditional software, you have to think about everything on your local machine, like your machine capacity, how much it can do for you, or whether you have sufficient drive space or the internet connectivity, whatever it is. When it comes to SaaS, it's pretty much about how you are connected to the internet, how your connection speed is, and so on. That becomes a prime important, and whether you have the latest browser or something that can run the SaaS software for you. Okay, so these are all there up there already, and what does it mean to us as a lab viewers in most of this? So traditionally, we have been using the various LabVIEW connectivity toolkits in order to connect everything on the local machines, right? You connect to a database or you connect to some DLL library or use a system execution to run another executable to get any output from that. Now we started to getting more connected to the web services when the SaaS comes into picture. Whatever has been running on your local machine might start to move to the cloud. One of the good example I would always say is a database. If you can see a Mongo database or Azure or GCP, Google Cloud. So all of them have a different databases, and the data that you are going to store now are going into the cloud. Here are just a different snapshot of various connectivity we use in LabVIEW. Definitely, on LabVIEW, we are having some new connectivities like web services and Python, which helps us to connect to an external world. But still, there are some limitations which I faced, and I try to overcome that. Here is still more examples of the traditional software that turning into a SaaS software. For example, the Excel, Microsoft Excel is already in SaaS, MongoDB, or your simple data, whatever the data it is. Everything taking us to a new paradigm where we will definitely be in a position we need to start connecting to the SaaS sooner or later. So usually, how does SaaS work? A SaaS usually have some services running up in the cloud that can help us to get connected from the local machine. Our application might run on that local machine, and that SaaS service can give some libraries, just like a DLL, right? It can give some API libraries, which we can make use, to get connected to it. And in most of the services, you will find something like an API key to exactly identify whether the right person is connecting to the SaaS service or whoever is authenticated to connect to the services is the one coming in or not. So the API key plays that role, and in most sense, it will be the JSON objects which plays exchange messages between the SaaS and the local applications. From your user application, you do some API calls or library method calls, and the SaaS will respond to that in some API responses. And these calls and responses usually goes in some object notions like JSON. And there comes our LabVIEW. Our LabVIEW is just yet another local application in most of the places wherever we develop. When I try to directly integrate the LabVIEW with the SaaS services, meaning when I wanted to call the SaaS service straight away, the API libraries right in the LabVIEW, there were some challenges which are like the SaaS APIs usually released in a Python packages, and we don't find the APIs ready with something like LabVIEW driver or LabVIEW libraries. And Python version is very key challenging one. Usually we will find the latest SaaS services will ask us to use the latest Python or very specific versions of Python. And the JSON format itself, the JSON data, as it gets into the SaaS services, the JSON structure will be so complex that we will be overwhelmed in developing in the LabVIEW. In LabVIEW, usually we need to form a cluster, and within the cluster, we want to structurize the JSON data structure so that it can go out and come in. But this JSON itself is very dynamic. The JSON object can be the same JSON object might have one data extra or one data left out, and understanding that and knowing every directions of the JSON that goes out and comment becomes very challenging. And moreover, we are trying to connect to a SaaS service, which is highly a moving target, meaning the development environment being used for maybe Python 3.7 today, and tomorrow or a month down, you will find it is the latest Python 3.9. So those becomes a very key challenge. On LabVIEW side, when we try to look at, we see the LabVIEW gives support for Python libraries, but those are limited to specific versions like version 2.7 or 3.6, and you can feed in that version which we want to select. So how did that work out eventually? So in the same structure, we have all different aspects like JSON objects, API response, API calls, SaaS service, everything. And when I develop a LabVIEW application, now I started introducing a intermediate Python layer, a wrapper kind of layer, where LabVIEW will interact with it, our usual way, right? So we usually introduce some wrapper which does the job of the rest of the things. So just like that, Python wrapper introduced, and that Python wrapper in turn will do all the stuffs. So that reduces a whole bunch of uh, challenges coming down. And why is the Python layer? To a very simple fact, most of the SaaS services, whatever I noticed, were giving a Python API. And the community support is very, very wide, and we can jump in and give any question or doubt about the Python or usage of it, and we can get some answer. And it's just like LabVIEW, it's quite easy to read and write, and the object orientation in that is very simpler. If you want to create a class in Python and create an objects in Python, everything works as an object. In fact, JSON is a kind of complete object data you are sending. So it makes more simpler to work with the Python layer. So how did I architect that? As I said, the LabVIEW was there, and the Python layer was here. And suppose if I have an email SaaS service, for an example. So if I want to communicate to that, what I do is I will have different methods on the LabVIEW layer, which, for example, a check mail or send some email. That will send a message first to a Python layer, and Python layer in turn will have its own producer and consumer for the sake of as a service, a local service. A Python layer will keep a producer and consumer, and so that producer basically sends a message to the consumer, and the consumer in turn will send a message to the specific module developed for that SaaS service. Here in this case, an email.py is developed just for connecting to that SaaS service. And when that SaaS service responds back, it receives back the data, and it will filter out the data whatever I need from that JSON huge object, and send it back to the producer and comes back to LabVIEW. So just like this, I will have different SaaS services like an email pay or uh, it could be a drive.py which can send the data to a drive, or a mongodb.py that can send data to a specific Mongo database, and so on. And the producer consumer here is mainly playing a role of a producer can always listen for the LabVIEW messages, and consumer will play the role of consume those messages and interact with the different services and send back that response from the service to the producer. And producer can let the LabVIEW know what is the response. And one more key thing that helped me while doing this is retaining the object references inside the Python. Few of the services needs your socket to be always open while it is connected. Once you have connected to some service, that socket needs to be always opened. Back then, in previous Python libraries provided by LabVIEW, we don't have the session reference out. By that time, when I was developing, that was a very critical challenge because each SaaS service needs to keep that socket open until all the exchanges are finished. Whereas in that instance, I have to do all the job in a single script so that I can open, do the job, and close it. And I could not do it part by part, meaning module by module. That challenge was really easier to overcome when I go with the intermediate Python layer. Okay. So I have a demo here. I have this previously recorded. It is just the same email architecture what I showed there. Sending a sample email from LabVIEW through this Python API service. Just before that, before we get into that, is there any question? Right, looks good. Let me see if I can share my audio here. Not really sure if I can share the audio. Probably I'll put it on a speaker. Uh, okay, I'll try to explain orally. I don't think it's going to work. Okay, so in this demo, what I'm having here is third-party mail server SaaS service, which has a third-party mail server SaaS service, which is MailerSend, and it has various API resources, just like what I explained. And we will we are going to send some of the emails. So how usually we will approach in such situation is we go to the API resources of such services, and we look for some getting started example, just like LabVIEW. We will find some examples about their use cases in GitHub or in some places. We can get that sample, and once we have the sample like this from some GitHub places, we can give it a try on it. And here I have that in a Visual Studio Code where I can run a Python interpreter, and from LabVIEW I will have my all different VAs developed. In this case, I have uh, a VI with and various input for an email, and on the block diagram side, it will just exchange the message to the Python layer via uh, a TCP/IP connection. So once the message goes into the Python IO server, and it will exchange the data to and fro of the SaaS service, and it will respond back the data I'm pretty much interested in it, and that comes back, and I will use that to do the further operations. Okay, so that's still not working. I try to share the speaker. So here, what I have here is the main Python core, in that which has a producer and a consumer thread that's running on the main Python code, and the producer thread keeps listening for the messages from LabVIEW side, and as soon as it listens, it has found any messages, it will send it to a right consumer, and the consumer in turn will send the data. Here, the consumer in turn will send the data to the right SaaS Python file. Here, in this case, the mail is in Python file, and in the mail and Python file, we usually have the different functions or the methods for different SaaS API calls. So it will go to the right functions in the mailers and Python, and it will then interact with the service and get the data back. So here I have the example, and in that example, as I showed, I have the simple TCP request from the front panel, and that goes to the Python server IO. That's actually the TCP communication to the Python script running behind the script that producer loop. And from the consumer response, it will decode and show in the front panel data. So now when I run this main Python file, it has a user interface, and I have the LabVIEW icon there, but it's not LabVIEW, it's a Python UI, and it shows a simple log, what's happening on that service. And when I execute this function from the LabVIEW, I usually have it filled up with unnecessary details, like what is the name, from name, and tool email, and so on. So I have these names, everything filled up. So when they are ready to send, when I hit the run button, so this message goes to that and goes through the Python server, and it has all the logs in there. And it has a response back here that email sent true, which was successful, and to auto response is a regular HTML response. And when I check that email in my email inbox, I find that that gets delivered whatever I sent just now. Yeah, and that separate executable, whatever you noticed, is completely independent executable. It can run on its own, or it doesn't even need a Python installed on the machine wherever it is executed. So if your SaaS service needs a specific Python version, say it's 3.9, and if you can't have that, you can have this standalone executable which has everything built in, and that will still help with the LabVIEW communication. And this is a typical script to build that executable PyInstaller space. Whatever you made Python script, main.py, whatever it is, and when you run this, the interpreter will build that exe for you. Yeah, that's pretty much it. Any questions?
Thanks very much, Ajay. It was yeah, a really interesting presentation. Like you said at the start, I think sort of SaaS platforms are definitely becoming more popular. Being able to connect to them will be quite valuable in the future, I think. Anybody got any questions?
Thanks, Tom. Yeah. Yes, Jasper said, yeah. Thanks, Jasper, for being here. Yeah, PyInstaller, I have been notified it could have a potential security risk in it, and we definitely have to look into those details, how risky it is, security terms, as long as we are having it internally, we find it's
Awesome. Ajay, what do you think the future is for this kind of stuff? Like when you kind of put this presentation together, was that with some practical experience that you can see that you might need to use this in the future, or was it just something you kind of had an interest in, or how did it kind of come about, and what do you see the future looking like? question must have offended Ajay and he's left. I think.
Chris, can you hear me?
Yes, yeah, I can hear you.
Yeah, sorry, I missed your question. Please come here.
I was just asking whether you had any views on what the future was for this in terms of sort of the practical sense of it. Like, what do you think it might look like in the future with LabVIEW connecting up to these services? What types of examples could you see that might be coming up?
You need a type of example for a LabVIEW users as specifically, or
yeah, like use cases for sort of SaaS platforms. What
yeah, I would say that a very quick use case could be uploading your data to a SaaS service, for example, a MongoDB or your Google Drive, right? Yeah. Your customers can quickly start asking you to upload the data to their own data drives, where they do their data analytics, for example. Most of the customers do the data analytics and they want the data to be in the same place in order to do that. So we basically essentially collect the data from different places, and that's where the LabVIEW will bridge between, and we might need such use cases or applications. Yeah.
And do you think performance-wise, like if you're looking for sort of, obviously when you're data logging and stuff, you're always thinking about performance and speed and all those kinds of things. Do you see any kind of challenges around that? I think this approach kind of handles that quite nicely.
Challenges around which one? Sorry.
Sort of performance of the data getting from sort of its acquisition point to where it's being logged.
Obviously, definitely we will see performance issues. So usually the buffering, even in my applications, some of my applications, I do a buffering. So an intermediate buffer definitely happens in the local place. And from that local place, there's maybe an extra application, a LabVIEW application, or the Python will start pushing the data one by one to the cloud service. Yeah.
Okay. Awesome. Oh, Steve's just asked whether you can make the code available as a demo.
Yeah, I do have that. I just remembered I was asked for sharing that code, and I just uploaded to GitHub just before the meeting.
Oh,
I had to share that. Yeah.
Awesome. Cyril's got a question. Any challenges deploying such applications? Is it easy to troubleshoot when on site?
Easy to troubleshoot when on site. This is so far is in the play area, I would say. It's in a sandbox. On site in a real production environment, we haven't tried it yet, so it's still in a sandbox. But we believe that with the explorations, it is definitely working for some extent, and maybe a stress testing necessary over week run will give a performance idea how it goes. Yeah.
Cool. All right, guys. Is there any other questions before we jump into the next thing? Real good. Awesome. Well, thanks again.